Let's talk about square-based right pyramids. Look at the example that's on your screen. EABCD is a square-based right pyramid with sides of 12 centimeters. The height of the pyramid is 9.5 centimeters. Calculate the length of EC. So basically what we have right now is a square, which is our base. Notice that they're only showing one of the measurements of the size of the square, which is 12. Obviously, we know this is 12 also. Our job is to figure out the length of EC. The height comes straight up from this apex, from the vertex E, straight to the center of the pyramid, which is point F. We don't know what FC is. We do know this forms a right angle because it is the height which is perpendicular to that base. It doesn't seem like it because of the way the drawing is, but you have to remember this is a 3D figure that is being drawn in a two-dimensional surface. So that is going to be a right triangle. And then our job is to find EC. Right now we have two unknowns. We don't know any of the interior angles, so we can't necessarily use the trig ratios, SOHCAHTOA, sine, cosine, tangent. Instead, I would like to use Pythagorean Theorem so that I can solve for EC, which is going to be the hypotenuse of that triangle, but I'm still missing FC. It's okay, because one of the things that we can do, we can work with this bottom square, and I can find this diagonal, okay? Because this is a square, this corner right here is a right angle. So I'm going to go ahead and draw 12, 12, and my job is to find the length of AC. So I'm going to use the Pythagorean theorem. 12 squared plus 12 squared is equal to AC squared. 144 plus 144 is equal to AC squared. 288 is equal to AC squared. Take the square root of both sides. That will cancel out the square with the AC. Take your calculator, find the square root of 288, which is approximately 16.97056275. So this is going to be AC. So now if I go to the other right triangle that I need so that I can solve for EC, this is going to be EFC. Notice that I don't need the entire length of AC. I just need from F to C. Well, what relationship exists between AC and FC? FC is going to be exactly half of AC. So here's the entire diagonal. Because F is at the center of that square base, then I know that FC is going to be half of AC. So I'm going to take the answer that I found previously, which is 16.97, and I'm going to divide that by 2. When I divide that by 2, I get that FC is going to be about 8.48528. Okay? So I'm going to use that information right here so that I can do the Pythagorean theorem once again. So this is about 8.49. I'm rounding on paper, but in my calculator, I'm going to keep all of those decimal values so that I avoid round off error. And this is 9.5. So I'm going to say 8.49 squared plus 9.5 squared is equal to EC squared. Remember what I told you, we kept the entire 8.485281374 in the calculator. I press square and it gives me 72 plus 9.5 squared, which is 90.25, and that's going to equal EC squared. Add them together, 162.25 is equal to EC squared. Take the square root of both sides. And then I get about 12.7 is going to be the length of EC. So the length of EC right now is going to be approximately 12.7 centimeters. Continuing with the same exact square pyramid, the problem continues. A point M is marked halfway along one side of the base. Calculate the length of EM. So what we're doing is now taking a look at one side of this pyramid, and we're going to call that M, which is the midpoint. Now the entire side was 12, which means that by finding the midpoint, we're going to cut each one into 6 and 6. So it says to calculate the length of EM. EM happens to be the slant height of that pyramid, one of the slant heights. So to figure out the length of EM, I'm going to go ahead and use the information that I already know. Remember that we found that EC is about 12.7. So EC being about 12.7, this forms a right angle right here. I'm going to redraw this. Here's EM and C. From M to C right now is 6. Remember, M is the midpoint, so instead of the entire side being 12, I cut it in half, 6 and 6. We know that EC is about 12.7, and our job now is to do the Pythagorean Theorem so that we can find EM. In this problem, the hypotenuse is 12.7. So I'm going to say 6 squared plus EM squared is equal to 12.7 squared. I know 6 squared is 36. Plus EM squared equals 12.7. Remember, is an approximated answer, but it is the last answer that we got in the calculator. So in my calculator, just like in your calculator, you should have the entire value of the decimal, 12.7377392. I'm going to go ahead and put square so that I can square that one and I don't get round off error. So I have 162.25 as my answer. I'm going to go ahead and subtract 36 from both sides to keep solving for EM. So EM squared is equal to 126.25. Go ahead and take the square root of both sides. And so EM is going to be approximately 11.2 centimeters. So EM is about 11.2 centimeters. It says, why is the length of EC not the same as EM? Well, if you remember, EC we found to be 12.7. And, oh yes, it's right here in the diagram. And EM we just found to be 11.2. Do realize that in my triangle, they don't represent exactly the same thing. So basically, you're looking at this triangle where EC is one of the edges right here, 12.7. And if this is M right here in the middle, this is D, then EM serves as the slant height, the height of that triangle right there. So obviously it has to be less than 12.7, which is the hypotenuse of that right triangle when I'm looking at this as two triangles that are right triangles. So they're not going to be the same. One of them is the edge, the other one is the slant height. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.